Here's a quick follow-up video on my Bale spike a season later. It's had about 100 bales through it. It's been pretty good. I did have to put this little collar here to stop the backstroke. You can kind of see it pulled this back, and I just re-welded it because I was about a 1/16 of an inch off and too short. I did notch my cross members for the cylinder to fit. It's a 4 by 12 inch stroke, 1.25 inch rod. And then my hinges are just pipe, and then they have a pin in them. Welded in, they're dry. I just knocked the pin out, and pretty much no wear for one season. There's the rear cylinder brace, the notch at the back to clear it, and then I just ran up to the fifth wheel plate with a piece of angle iron to help hold it. Another thing I'd recommend is using these swivel fittings. So you can use a standard NPT hose, and then if you blow one on a weekend, you can just go to Tractor Supply or your local farm store and get a replacement, not have to make a special trip to a hydraulic shop or something. So I've had a few questions on how to size cylinders for this. We'll start with the stroke. So you'll take your hinge point to where your cylinder mounts, you'll measure that. Mine happened to be 8 inches. So then laid over flat, it'll be the same length. And that makes a triangle. So you find A and B, we know them, and we're looking for C. So we'll take A squared plus B squared equals C. So mine would be 8 times 8 plus 8 times 8 equals 128. Then you'll get the square root of that, and that'll be 11.31 inches. And then we will round up to 12 inches because that's a standard cylinder size. And then for the diameter, when you're picking up, you're retracting the cylinder. So the fluid will come in here, and we need to know the annular area, which is what's shaded, kind of like frosting on a cookie. So that's the bore minus the area of the rod. So on a 3-inch one, you can go 3 by 3, make a square, times 0.7852 gives you 7.06 inches squared for the area. And then 1.25 inch rod will be, 1.25 by 1.25 times 78.5% equals 1.23 inches squared. So then subtract 7 from 1.23 from 7 gives you a 5.80 annular area. And then to compare, here's a 4-inch one, similar math, and then you have 12.56 minus the 1.23, and that gives you 11 inches, 11 1/3 inches squared. So then we'll use a 5 by 6 bale, round bale, figure it at 2,000 pounds, kind of like a heavy silage bale, so we're safe. So it'll be 5 feet wide, 6 feet tall. The middle will be 2.5 feet out. So you take your weight, 2,000 pounds, times 2.5 feet out, gets you a 5,000 pound force in the middle that we have to pick up. So then that comes into play. You take your 5,000 pounds on this on 3-inch, and you'll divide it by your area. And that gives us 857 PSI to lift that load. On a 4-inch, it'll give you 441 PSI. And then a 2-inch, doing the same calculations, gives you 2,617. And on a 2,500 pound system, PSI system, you will not lift that, and you'll be disappointed. So you can do it with a 3, you can definitely do it with a 4. The advantage of going bigger is less overall stress on your system, less pressure, then you're less likely to blow a hose or a seal later on in life. Hopefully this helps somebody and answers a few questions. Please feel free to ask if you got others, and I'll try and answer them.